Frozen plains, mountains with white peaks glistening in the distant sun, and rustic red snow. Welcome to Pluto, where nothing makes sense anymore. Looking at it from a distance, the ice ball planet is mostly predictably winter shades of white and light blue. Once you land on the surface, you'll notice familiar blue skies as well. But see that whale-shaped red stain running along the equator? Right there to the left of the white heart-shaped region, there she blows. This spot is bigger than Alaska, and it's a mystery to scientists. That's not red clay soil or anything you'll see on Earth. That's Pluto's version of ice. Scientists believe it's red because the atmosphere drops this strange soot-like chemical called tholin on the surface. It's the same stuff that explains the red cap on Pluto's moon Charon. Now, let's zoom in closer on the whale. Oh look, we have a mountain range. Yes, Pluto's red ice is like rock, hard enough to form entire mountains. Those white peaks standing out against the dark red aren't snowy caps like we have on Earth. That's frozen methane. For such a small planet, Pluto's mountains are epic, bigger than Everest and made entirely of ice. Such a bizarre landscape can't be found anywhere else in our solar system. Yeah, Pluto's a pretty harsh cold place. Temperatures there can dip to minus 400 degrees Fahrenheit. The coldest ever recorded on Earth was in Antarctica, a measly minus 135. Now let's head back to the heart of Pluto. That's actually a vast plain covered in nitrogen ice. Scientists discovered that Pluto's heart makes the winds on the planet blow. Craters are also big, and some of them show signs of filling and erosion. That's something that happens right here on Earth. When land is worn away and shaped by natural forces like wind, water, and ice, that's erosion. So, what makes all this so special on Pluto? It could be evidence of tectonic plate activity. You know, big plates of land surfing on liquid rock, forming mountain chains, breaking continents apart, putting them back together. That's something scientists so far have only ever seen on Earth, not on any other planet in the solar system. Now, looks like Pluto could be more like our own planet. That, and there's water on Pluto, 1/3 of its surface in fact. But of course, it's not like Earth water. It's more like a rocky slushy. Yum. Still, no signs of life out there, at least not for now. It's taken a long time to get the little information we know about Pluto. It was first discovered almost 100 years ago and deemed the 9th planet from the Sun, until 2006 when its official planet membership card was revoked. Poor Pluto. It was dubbed the biggest dwarf planet in the Kuiper Belt, a region outside our solar system full of other dwarf planets and icy bodies circling the Sun. A few months before that, they launched the New Horizons mission. It was the first space probe researchers sent to Pluto in 2006. Zipping at over 35,000 miles per hour, that's 45 times the speed of sound, it still took the probe almost a decade to reach its destination. That's how far away the tiny planet is. In fact, Pluto is nearly 40 times the distance from Earth to the Sun. If you were there looking up at the sky, you'd see the Sun as a tiny dot like any other star in the sky. Once New Horizons finally reached Pluto in 2015, it got close enough to get some incredible pictures of the surface. It also collected important data and observations, like those strange red spots and that heart-shaped region. But Pluto gets even stranger, especially its orbit. Most other planets go around the Sun in almost perfect circles with the Sun close to the center. The Sun is nowhere near the center of Pluto's orbit, and the orbit is so stretched out that Pluto sometimes crosses into Neptune's path and gets closer to the Sun than the blue gas giant. So, the unusual effect of this strange orbit? Pluto sometimes has an atmosphere, and sometimes not. When it's closer to the Sun, a thin atmosphere of nitrogen forms. But once the planet starts moving further away from our Sun, the atmosphere freezes and falls to the surface in an ice storm of epic proportions. Pluto is probably a lot smaller than you imagine. If you put it on a map of the Earth, it would only span about halfway across the US. Yet this little planet has 5 moons spinning around it. And life on Pluto would be one endless year for us humans. Imagine no birthdays your whole life. Since it was discovered in 1930, we still haven't seen it complete a full circle around the Sun. 1 year on Pluto is 248 Earth years, and we'll finally see that happen on March 23, 2178. Mark your calendar. Since Pluto got kicked out of the official Planet Club, Neptune became the last one in line. It's actually a big ball of ice and gas. So, like with the other gas giants, if you tried to land on this planet, you'd just keep going deeper and deeper into seemingly endless clouds and atmosphere. Funny thing about the blue planet, it might not have a rocky surface like you and I are used to, but its surface-level gravity is about the same as Earth's. Same can't be said for any other planet in the solar system. As we make our way closer to the Sun, we pass the next gas giant, Uranus, that non-conformist planet that goes around the Sun basically rolling on its side. One full orbit is 84 Earth years, so you might be lucky enough to celebrate your first birthday in your whole life there. Only one party, so you better make it count. And now we approach the jewel of the solar system, Saturn, the second biggest planet after Jupiter and another gas giant where you'd sink in an endless atmosphere if you tried to land a spaceship there. Saturn is the least dense planet of them all, meaning if you put it in a giant glass of water, it'd float. Those famous rings are made up of dust, ice, and rock. Some as tiny as a grain of sand, others bigger than houses. But get this, Saturn's rings are raining down on the planet, enough to fill an Olympic-sized pool in a half an hour. At that rate, the famous blue ring system will disappear completely in 300 million years. By the way, Neptune, Uranus, and Jupiter also have rings. They're just not as visible and bright as Saturn's. Imagine combining all the planets into one. Now make it 2 times bigger. Still not as large as Jupiter. Scientists called it a failed star, since it's mostly made of helium and hydrogen, just like our Sun. But jumbo-sized Jupiter still isn't massive enough to kickstart the chemical processes that could turn it into a star. It's the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Imagine trying to squeeze sleep, work, friends, hobbies, movies, shopping, your whole routine in less than half an Earth day. Magnificent tall mountains, the highest in the entire solar system. The most epic dust storms ever. Deep valleys, craters. I'm talking Mars, our potential home in the future. If you love sunsets, you'd definitely enjoy Martian ones. They're incredibly blue, while the sky throughout the day is pinkish red. Even though Mars is our closest neighbor, from the surface, the Sun would look half the size it does from Earth. So, not as close as it seems. Oh, and if you always dreamed of becoming a basketball player, Mars is your place. The red planet's gravity is only 37% of Earth's, so you jump 3 times higher there. Venus is a planet of extremes. The hottest surface, the most volcanoes, the brightest planet, and the closest one to Earth. It's also the slowest spinning and barely rotates, making a day on Venus last 243 Earth days. You could literally walk faster before the planet makes a complete turn. Venus also rotates in the opposite direction that Earth does, so sunrises are in the west and the sun sets in the east. Mercury. It doesn't have any moons or rings, and we're talking about the smallest planet in the whole solar system. A year lasts only 88 days, so if you live there, you'd have a lot of birthdays. Mercury is the closest planet to the Sun, but it's actually not the hottest. That prize goes to Venus. Temperatures on Mercury don't get as high as on Venus because it doesn't have an atmosphere to trap heat from the Sun. What Mercury does have is wrinkles. Its iron core cooled and shrank, causing the surface to contract too, and leaving all those wrinkles. That, or because it's so close to the Sun with no SPF. Maybe.
You won't believe it! People make wishes when they see shooting stars!
Yes, they think that asteroids makes their wishes come true.
May I stay with you? Ooh, and who's this cute little guy with the heart on his side?
You're not even a planet, babe. You won't understand anything anyway. Try playing with Jupiter. He will introduce you to the satellites.
I repeat that I am a planet. Play with your satellites yourself.
We've already discussed it, Pluto. You used to be called a planet, but let's face it, you can't hang out with us. Our interests differ too much. We are full-size planets, and you are a dwarf planet.
Don't listen to him, Pluto. Size doesn't matter. You're a strong and powerful planet. I will sue you and make you play with me.
Don't lose your heart, Pluto. Maybe you are a former planet, but you have an atmosphere, organic compounds, and even satellites, and a heart.
I am not a former planet!
And I didn't tell him about the existence of a mysterious planet, which, as scientists predict, will take the place of Pluto.
Oh no, too many tragedies for one day. We have had enough tragedies for today.
The party crasher.
Oops.
Our good old solar system is actually a pretty bizarre place, what with all its out-of-this-world phenomena that we humans haven't managed to explain yet. There are rumors that a gigantic, undiscovered planet is hiding behind Neptune, volcanoes on Pluto spew ice, and a colossal canyon on Mars can accommodate the whole U.S. territory and most of Cleveland. Well, let's figure out if it's true by talking about the most mystifying solar system facts. The solar system is 4.6 billion years old. So old it's a senior solar system. Scientists came to this conclusion after they studied the oldest material they managed to get a hold of. And by that, I mean meteorites, of course. You won't be able to wear a hat on Venus, ever, and just try to stand on your feet. The planet is insanely windy. Its upper winds blow 50 times faster than the planet rotates. What's more, these fierce winds never stop and can get even stronger with time. Want to get away? You'll have to travel 11 billion miles away from Earth before ever leaving the solar system. Take your Google Maps with you. You probably heard of methane gas, a byproduct of natural processes such as volcanic activity and cows. Anyway, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be cows on Mars? As you may remember, Pluto used to be a planet but was stripped of this title in 2006. Later, it was reclassified as a dwarf planet. Gee, make up your mind. But the most unexpected fact about this celestial body is that its diameter is smaller than that of the US. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,800 miles. As for Pluto, it's only 1,473 miles across. The planet Uranus, or Uranus, you can't win either way, rotates on its side, and astronomers have no idea why the planet has chosen such an unusual position. The culprits could be ancient mega-powerful collisions, but so far it's just a theory. By the way, this is the only planet laying on its side. Our Sun is insanely massive. Want some proof? Well, 99.86% of all the mass in the solar system is in the mass of the Sun, in particular the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Earth might not be the only tectonically active planet in the solar system. Astronomers have spotted some landforms looking like cliffs on Mercury. If it's so, the tectonic activity could explain the rapid shrinking of the planet. In most sci-fi movies about space, the main character gets into an asteroid belt and must dodge countless rocks that threaten to damage their spacecraft. Well, sorry to disappoint, but that's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that the chance of collision is next to nothing. You just ruined it. Sorry. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists can't explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet from our sight. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. Volcanoes on Earth are as different from those on Pluto as fire and ice, and I mean it. While we have volcanoes spilling lava on our planet, the volcanoes on Pluto spit ice. When frozen water expands, and this enormous pressure builds up until one day, bang, the ice erupts. In the process, a new cryovolcano gets formed. One of Saturn's moons, Lepidus, has a unique color. It's two-toned. One of its hemispheres is light and the other is eerily dark. Scientists haven't figured out this mystery yet. There's another weird thing about Pluto, or rather, about its atmosphere. First, it rises way higher above the surface of the dwarf planet than, for example, the Earth's atmosphere. What's more, the atmosphere on Pluto has more than 20 layers, and all of them are super cold and very condensed. We live inside the Sun. No, I don't mean that we're inhabitants of the red-hot ball of light approximately 93 million miles away. The thing is that the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, it's the gusts of solar wind that create the breathtaking phenomenon known as the Northern and Southern Lights. The ocean on Jupiter is larger than any other on the rest of the solar system's planets. But wait! It's not the type of ocean you're thinking about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is a staggering 25,000 miles, which is almost the same as the circumference of the Earth. The Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. People came to know about Saturn's beautiful rings in the 1600s, but only recently it became apparent that Saturn isn't the only ringed planet. All the gas giant planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky materials and have no rings whatsoever. Our solar system isn't the only one in the Milky Way galaxy. Far from it. The galaxy we live in houses about 100 billion solar systems. And if that's just our galaxy alone, can you imagine how many there are in the whole universe? At any given moment here on Earth, you can stumble across a rock that's arrived from Mars. After scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places on our planet, they came to the shocking conclusion that they have a Martian origin. Since Mercury is the closest planet to the Sun, many people simply assume that it's also the hottest, and that's where they get it wrong, because, in fact, Venus, which is about 30 million miles further from the Sun than Mercury, is way hotter. The thing is that Venus has an incredibly thick atmosphere, which is 100 times denser than the one we have on Earth. On top of that, this atmosphere consists almost entirely of carbon dioxide, also known as a greenhouse gas. These factors make the temperatures on the planet rise to a staggering 875 degrees Fahrenheit, which is hot enough to melt lead. As for Mercury, its maximum temperatures reach only 800 degrees. Jupiter's moon, Io, exists in never-ending chaos due to hundreds of smoking volcanoes on its surface. If you ever visit this place, send me a postcard. Now, you'll see the smoke from these volcanoes billowing up high into Io's atmosphere. The most enormous volcano in the whole solar system, at least that we know of, is on Mars. The size of this monster is almost as great as the state of Arizona, and its height is as big as that of Mount Everest. How did it grow this huge? The answer is simple. There's much less gravity on Mars in comparison with our planet. Even if you're a tiny celestial body, you can still have a moon of your own. Hey, it's not that hard. In 1993, the Galileo probe was traveling past a miniature asteroid that was no bigger than 20 miles across, and discovered the little thing had a 1-mile-wide moon. Since then, astronomers have found tons of moons orbiting minor planets in our solar system. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. And it's another thing that puzzles astronomers. After all, Mars isn't a planet with active plate tectonics. On the surface of Jupiter, there's a weird region that's called the Great Red Spot. Recently, astronomers have concluded that this spot is actually a storm that's been raging on the planet for centuries. But some 20 years ago, scientists noticed that the red region started to shrink. Nowadays, it's just half the size it used to be. And still, the spot is 1.5 times bigger than Earth. How about you? Do you know any other unusual facts about our solar system that I've missed? Then let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But hey, don't go space traveling just yet. We have over 2,000 cool videos for you to check out. All you have to do is pick the left or right video, click on it, and enjoy. Stay on the bright side of life.
What would happen to us and our planet if it became as big as the Sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the Sun, about 865,000 miles. Compared to our Earth, the Sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the Sun. Scenario 1. The Earth becomes as large as the Sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. We'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. This scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new Sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the Sun and gets its mass. Now we have 2 suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having 2 centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining ex-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our 2-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the sun. It's almost 110 times larger than the Earth. Our new Earth's equator equals our current Earth's 35 equators. Oh, and remember Pluto? Well, it's our only moon now. The first one would have probably crashed into us a long time ago, making us share the fate of the dinosaurs. In that case, all the water would likely evaporate from our planet. Anyway, there are thousands of bad possibilities, but let's just move on and focus on something good. Scenario 3. Same thing, but the Earth retains its density. Now this one is interesting. We're no longer a planet. We're a star now. In fact, we became even more massive than the Sun. Our planet now has a 3.9 solar mass because we need to balance our low density somehow. In short, it would be almost the same as in Scenario 2, but with more interesting long-term consequences. Since our Earth became 4 times as massive as the Sun, it would have burned its fuel quicker. Then it would evolve, and depending on the mass of its core, it either becomes a supernova or just blows off its outer layers to form a planetary nebula. If it goes supernova, the Sun that was so close to us blasts, and now there is just our ex-Earth, a lonely ball with a teeny tiny diameter of 12.5 miles. We're a neutron star. That is, a star made of degenerate neutron matter. That thing is ultra dense and spins very quickly, so you'd better stay away from it. If the Earth becomes a nebula, the Sun collects all the dust and adds it to its mass. Now we have a slightly more massive Sun and a white dwarf. The time passes, and Grandpa Sun lives out his life. It becomes a red giant after depleting the hydrogen in its core. It starts expanding and leaves its material, mostly hydrogen, on the white dwarf. That's us. When the matter reaches high enough temperatures and pressures, nuclear fusion happens. We become a nova. Yay, we're a star again. A lonely one, but a star nevertheless. So what happens next? You see, a star is a battle of opposing forces. One of them is gravity, which tries in every possible way to compress the lead into a small ball as much as possible. The second is a pile of fuel in the star's core, which, while burning, forms tons of energy and substantial hot temperatures. As long as these forces are in balance, the star lives. But when the star's fuel runs out, the star cools down. The pressure inside it drops. This means gravity has won. It squeezes the star with all its might, and as a result, the star goes, hooray! In just 15 seconds, the brightest light you've ever seen in your life flashes, and our ex-Earth goes supernova, leaving a stunning nebula behind. Anyway, don't worry. It's actually impossible for a rocky planet to be the size of the Sun. Only other stars can be that large. But wait, why is our Earth so small while the other planets are enormous? Do they just keep growing, or do they stop at some point? The more mass you add, the more compression you get. As planets become more massive, the gravitational compression increases. They stop growing when their mass reaches roughly 1.7 times that of Jupiter, or 540 masses of the Earth. After that, adding more mass to a planet will make it smaller, because the compression becomes stronger. In other words, our little thought experiment is impossible.